Process of documenting older projects I did. This was done in 2009. Really at the point in time I just wanted a good infrared light and nothing was available on the market. So basic concept here, this is 3-inch PVC, and if you notice you'll see there's a lens in there. I'll get into it and show a little bit more of how this is produced. Essentially this is a coupling, and what you do is cut some PVC, put it in and make that lip, and then from there put in a lens, and the other side of it it's pinned with another piece and screw in to hold this front piece here. Screws aren't perfect, could have been a little bit better, some of them are better. Now the reason this is a screw-in piece coupling, half screw half pipe pushing, so this is a perfectly smooth side to accept a 3-inch PVC. This side is screw on, and then this is another end coupling. This is a female, this is the male to the coupling. These are all I believe it's ordinary PVC. I don't think it's CPVC. Then the handle is 3/4 inch PVC. Again, nothing too great, but took a little doing to get that curve right. There's a bolt running straight in, which I doubt is visible, possibly barely visible, I don't know. But there's a bolt running through, and that goes up inside. Let me open it and show the inside. This is just the output. What we have here, it's meant to fit flat, nice and flush. This is a backing plate that was fabricated. Again, cutting a ring, fitting the ring in, 3-inch ring, and then sticking a piece. It's starting to separate. This was all obviously lightish yellowish and was sprayed. Speaker wire, a little bit of a flex connection there. So basically put this jumpers, and I've already put a plug on this. So let me open the inside and show how it looks inside. What was done, white was done. Before the ring was put in, it's a split. You don't get this size PVC very easily, so what you do is sleeve it and put in a split ring and then just stick it on. As I said, it was a yellowish color. This came, and this is the sleeve, 3-inch sleeve, and then that's the ring. This is from my magnifying glass, and basically it's a lens. Reason for this lens I will explain a little bit further. And as I said, female coupling threaded on one side, male coupling threaded on one side. Right, this was an attempt at actually creating a reflector with gift wrapping paper. Didn't work out the greatest, but it's a funnel cut and wrapped. At the point in time when this was built, it looked pretty well. It worked well. It was pretty good. How this is done is banked. These are 5 LEDs together, and each one of them, if you look on the side, has this limiting resistor. So what I did is I put the 5 of them in series, and one limiting resistor. Work out the resistance to get the correct MA for this. These would have been run at about 25, I would think. I normally don't run quite 30. These probably would have been rated at 30. These are 940s, so this was not available on the market in terms of a larger wattage. This was done, as I said, in 2009. So yes, we're talking, you know, of the order of about 8 or 9 years ago. So yes, you could not have gotten 1 watt, 2 watts, or any kind of, you know, powerful LED lights. So this is what you could have gotten, 5, and well, perf board, soldered up, nothing complex, just a power supply coming in and limiting resistors, a bank of LEDs. Right, this described already. Now the reason that this is a male threaded, female threaded, is to turn and adjust. Interestingly, when you turn and you adjust, you can actually make these LEDs have a reflector plate that causes them to basically have a distributed light angle. I can't recall if these were 15 or 30 degree angles, might have been 30. Anyway, when you power this up, alright, and you use a lens like this, you can actually focus these and bring them back in Right, so instead of a diffuse light, you get a much more concentrated beam, and it goes a lot further, so you could use it as a spotlight. And that was the intention of this. This was essentially an infrared spotlight for me to use, and you could pick up things with your ordinary cameras that you would not have been able to pick up with out having a spotlight, but it's invisible to the human eye at least. I will try to put this on and take a picture of the distribution pattern and how when you turn it, how it focuses in a little bit later when the place gets dark. That said, I'm not sure easy to show on camera that this is infrared and invisible to the human eye. Obviously, it would be visible for the camera for me to pick it up, and that means that basically, well, you have to be here in person to understand that it is invisible to the human eye. Just a little note here, I'm working on the side, I'm seeing B. This is how I always label everything. This is the back of the plate, the inside. So I label everything to make sure, I don't put anything in the wrong place. And clearly there's a identifying mark again, and that shows me this lines up with this and fits perfectly in this position. So later when the place gets dark, I will make one run of it. This is 12 volts by the way, and well, we'll see how it fares and if it is possible using night vision on the camera to show the difference between night vision, day vision, and clearly show that it is in fact an infrared LED. Okay, and this is a view of it from on top, not connected, 0 on the ammeter, and let's see what we're getting. Right, with it on, I'm getting 98 milliamps, and if you look in there, you could see actually this is enough to show that it is in fact infrared. If you look, you would see those are not white LEDs. On a final note, I was unable to actually show the focusing by turning the threaded pieces, simply because the filter on the phone is actually that good. At 940 it picks up nothing, so yeah, no view. This was on a much less sensitive device, and I also had webcam, so I removed the IR filter, so I got vision into the infrared range. Beyond that, just touching back based on the let's say 100 ME thereabouts. Partly the reason that is a little low is because I'm just recording now that this was designed ready to operate in a car, and that's why these wires remain hanging. I did not have a good card, cigarette lighter jack at the time. So yeah, that really runs at about 13.2, sometimes closer to 14 volts, and you have to be conservative. With 6 of them, say 100, let's say we are about 15, 16, give or take, right? ME, that's running low. But if I was at 13.2 volts, I'd probably be closer to the 30 ME anyway. So being conservative, not wanting to burn out my LEDs, that's why it's running low. And the power supply that I use here is a computer power supply, so that's a dead 12 volts. No, nothing above that. A card doesn't really give 12. So that's just finishing off and capping off this. As I said, it's just documentation of projects I did before, so that there's something to reference in case I'm talking about it, in case I'm doing anything in the future. It's just reference information.